Hello, good morning. We are the team number 6 and we will talk about the Kepler's law. My team is made up of José González Rosas, Pablo García Beltrán, Cintia Baltasares Hernández, Alan Gandara Medrano, José Duarte Hernández, and me, Jeffrey Cortés Cantoran.
First of all, we will know a little about the author. Johannes Kepler was an astronomer and mathematical German that revolutionized Ciencias. He was born in 1571 in Württemberg and died on 1630 in Regensburg. His main apportation are the laws that govern the movement and the planets. Laws that bear his name and were published in 1609 and 1619. Besides, contributed in optics in 1604 and discovered two new regulars, polyhedra in 1619, among others. Kepler's law will be explained below.
Hello, I am going to talk about the first law of Kepler. The first law of Kepler dictates the planets in the solar system have elliptic orbits with the Sun at one of the two foci. As a consequence of this law, the planets' orbits follow the general equation of the ellipses, and they have geometric properties of the same. For example, an eccentricity, a semi-major and minor axis, as well as a perihelion and an aphelion. The perihelion is the point in the orbit where the planet is the closest to the Sun, and the aphelion is the point in the orbit where the planet is the farthest to the Sun. In this manner, the planet has its maximum velocity in the perihelion. On the other hand, the planet has its minimum velocity in the aphelion. In conclusion, this law helps us to understand the dynamics of the planets and their movements.
The second law of planetary motion states that the line drawn from the center of the Sun to the center of the planet will sweep out equal areas in equal intervals of time. It is sometimes also referred to as the law of equal areas. It explains the speed with which a moves while orbiting around the Sun. The planets don't move at a constant, but when the planets are close to the Sun, their speed is compared to their speed when the planets are further away from the Sun. Hence, we can say that the area swept by the Earth indeed is.
Kepler's third law is known as the A of the periods. This law allows us to compare the planetary movements for that the orbital period and the radius of the orbit of each planet are taken into account. Known as the dead psi is if we divide the square of the orbital time by the cube of the radius of the orbit, we obtain a constant k called Kepler's constant, which is the same of every celestial body that orbits around the Sun and formulates it to represent what is commented is this. Now we have a table in which we can see that the value of k is practically the same for all the planets. For example, to calculate the constant in Mercury, we must put the orbital period squared, in this case 0.241, and divide it by the radius of the orbit cubed. Cubed in the case its radius is equal to 0.387, and solving that we obtain the Kepler's constant.
Kepler is mainly known by the three laws of the planetary movement, but there is another contribution to physics and physiology that is unnoticed, and it is the model of the human eye. He took the previous knowledge about the eye, like the function of the retina and the crystalline, and the knowledge of lenses, and he was the first person to consider the human eye as a dark camera, constituted by a converging lens, which is the crystalline, and a screen, which is the retina, where the pupil works like the hole where the light gets in a dark camera. The crystalline works like a lens, and the retina works like the screen where the image is projected. According to this model, the image is projected upside down, and the brain interprets it correctly. And this is how actually the human eye works.
In conclusion, Jonas Kepler was a very good scientist who lived in the years 1571 to the year 1630. He is credited with the formulating the laws known as the Kepler's laws, which are three. The first, law of orbits. The first law, known as the law of orbits, ends the idea also held by Copernicus that the orbits should be circular. The second law, of areas. The second law, known as the law of areas, gives us information about the speed at which the planet is moving. And the third law, the law of periods. The third law, known as the harmonic of the periods, relates the periods of the planets. That is, how long it takes to complete one revolution around the sun and with their medium radius. And when can Kepler's law be used? In principle, Kepler deduced these three laws from the observation of the movement of the planets around the sun. However, thanks to them, we can also study the motion of any body orbiting the sun, such as planets or asteroids or kites, and also the satellites orbiting around the planet, such as natural satellites, for example the moon, or artificial satellites. That is all for us. Thank you very much for watching, and I hope you enjoy this presentation.